Hello, I am Julius. Welcome to my channel. Please like this video. For those one who are new to my channel, please subscribe. In the previous video, we looked at a ladder problem that talks about a man climbing up a ladder and at what distance would he climb before the ladder would slip off. And in that problem, there was coefficient of friction at the wall, and today we have both wall and the ground having coefficient of friction. So let us get started with our question here. The question says, a uniform ladder rests in a limiting equilibrium with its top end against a rough vertical wall and its lower end on a rough horizontal floor. If the coefficients of friction at the top and foot of the ladder are 2/3 and 1/4 respectively, find the angle which the ladder make with the floor. Now we're requested to find the angle with which the ladder will have to be inclined for it to be at this limiting equilibrium. So we don't know the angle, and it's represented by an unknown letter theta. So from this geometry, you'll see that this angle is also theta. Likewise here is also theta. So let's name this normal reaction here to be R of the ground to this ladder at the bottom. And then we have the normal reaction S of the wall on this ladder. Then since the wall and the ground is rough, we have the frictional force F equals, from our question here, we're saying the coefficient of friction at the top. At up here, our F is represented by 2/3 of the normal reaction to the wall, which is S. And then at the bottom is 1/4 of our normal reaction at the bottom, that is R. So that is one important information we need to get from there. And then we have to draw also some dotted line here such that our angle theta will also be the same here as theta. Now the question has not specified the length of this ladder, so you're free to choose any of these length of your choice. And in such kind of questions where frictional force has been involved in both the vertical wall and the horizontal plane here or the ground, it involves a lot of work. So let's get started by selecting the length. As we'll select saying 2L, so will be at the length of this ladder to avoid too much fractions that will get involved during our way. If that is 2L, it means the distance from the bottom of this ladder up to the middle will be L. Likewise here, also L. Great. So we proceed ahead and resolve these forces vertically and horizontally to obtain some important results. There are a lot of unknown things here. And again, before we resolve and we look at the weight of this ladder, has not been also specified how heavy it is. So we can represent this by a letter W representing weight. So I'll have here W representing our weight. So let's resolve vertically. resolving vertically, it means in that direction positive. We shall have three forces which are vertical, 1, 2, and 3. So 2 are acting upwards in the direction positive, and 1, which is the weight of this ladder, acting downward, which is negative. So let's start with this one, that our R plus our F, and that F, for that case, we write it in terms of S, 2/3 S, minus the weight must give us 0. The sum of all forces along the vertical axis equals to 0. So from here, we have generated one equation. Call this one equation number 1. Let's resolve horizontally. In that direction positive. There are two horizontal components, this one and the other one here. So we shall have the sum of the forces along x-axis will give us 0. So the one to the positive direction is S, meaning S is going minus F must give us 0. So S is equals to F. But again, we know that our F here has been a quarter R. So let's rewrite R in terms of S. Therefore, R, when multiplied both sides by 4, we shall have 4S. Let's call this one here equation number 2. And the next one is taking moments. So before we take moments, let's have this as point A of the ladder resting on the ground, and point B of the ladder resting in this vertical plane. So we get another equation, because I'm seeing some 3 unknowns here which can be solved only in 3 equations. So taking moments, about point A. By taking moments about this point, you will eliminate R and F, and we can get to solve here another point of reference where all anti-clockwise will be positive and all clockwise will be negative. So looking at our diagram here, we shall start with the forces that will give us anti-clockwise. So when you look at this one, the weight will give us anti-clockwise, because when we resolve it along this dotted line, it will be perpendicular to this length, and it will be moving this way. When point A is fixed, it will be moving anti-clockwise, which is positive. And the remaining one, this and the other one, will give us clockwise, which will be negative. So let's move on and see. The first one is the weight of the ladder, which is W. So its length is L. So we'll multiply L by the resolution of W along that dotted line. So that's going to be cosine of theta, and that is the only anti-clockwise force. So we move to the next one, and that is going to be our S. When we also resolve it along that vertical line horizontal to this plane, we shall have it, the length now will be twice L. So I shall have twice L. It's going to multiply S, and S will be resolved. That is going to be sine of the angle theta. And then let's not also forget about the other one up there. We need to also resolve it along this direction, so that we shall have the length the same because they are at the same point. So we shall have 2L times, let's make it in terms of 2/3 S, and that is going to be cosine theta, and all that is going to give us what? 0. So meaning the sum of all the torques always give us 0. Right. So after having this step done, we will have to substitute these equations in this. So let's first simplify this equation in terms of W. Then we shall have something similar to putting equation 2 in equation 1. Our equation 2 is where there's R, we're substituting it through there. So our equation 1 looks like R plus twice, 2/3S. Let me take W to the other side. And then R is 4S plus 2/3 S equals to W. The whole of this one is over 1. So when you get an LCM here, this is 3. 3 by this is going to make 12S plus this is 2S must give us our W. So we have here 14/3S equals to W. Let's make S in terms of W. So we shall have here 3/14 W. So after having this, we have to substitute this one here where there is S, so that we reduce this a lot of unknowns, L, W, theta, in order for us to be able to get our theta next time somewhere. Okay, so our S is here smiling at us. LW cosine of theta minus 2L. Then our S has been 3/14 W sine of theta minus, so this one will have to be 4/3. Again, our S is 3/14 W cosine of theta must give us 0. So after coming to this stage, you can see that there's some few things we can simplify them here. When we cancel this one here by 2, making 7, this 3 goes there by 2. We also have here 7. and we can rewrite it to make it a little bit simpler. Our LW cosine of theta, the remaining thing here are going to be 3 over 7 LW sine of theta, and the remaining thing here is going to be 2 over 7 L was somewhere here, LW cosine of theta equals to 0. Wow, we are moving so well and so greatly. And we can quickly look at this one here. LW is common everywhere, so when you divide it through by LW, even here it goes to that. And then let us push on and continue reducing it down. Now from here, our work, we are left here with cos theta minus 3 over 7 sine theta minus 2 over 7 cos theta equals to 0. The good news is I'm seeing sine and cos only, so if I divide both sides by cosine throughout, cos theta by cos theta, 37 sine theta by cos theta, 27 cos theta by cos theta equals to cos 0 cos theta. This one vanishes to 0. We are saying that this one cancels down to 1, and then this one becomes tangent, so I'll have 3 over 7 tangent theta minus 2 over 7 equals to 0. So we need to subtract 1 minus 2 over 7, that is 5. 5 over 7, the result of subtracting this minus that, minus 3 over 7 tan theta is equals to 0. So we can arrange this one by taking it to the other side. We shall have this 5 over 7 equals 3 over 7 tan theta, and then dividing it through by this, we shall have 5 over 7 term is interchanging numerator and denominator, must give us tan theta. So when you look at this, our 7 will cancel with this one, and we shall be left with 5. We shall be left with 5 over 3 is equals to tan theta. So now our theta would be equivalent to the tan inverse of our fraction 5 over 3. Then our theta from a calculator, we have tan inverse of 5 over 3, giving us 59.04 degrees. So that is the angle required for this thing to be at that equilibrium. Therefore, we can make some conclusion saying the angle the lather makes with the flour is 59.04 degrees. Thank you very much for watching. See you next time, the next video. Please like this video and subscribe to get more videos from my channel. Bye.